We are studying chapter number 5 in Maths 2, which is coordinate geometry. We have already spent two or three classes actually, looking at the basics of coordinate geometry. Then we looked at the basic knowledge about distance formula. And in the last class, we solved a lot of questions and we saw how the distance formula can be applied, not just to find distance between 2 points, but also to comment about triangles, to comment about different quadrilaterals, especially parallelograms. And we completed practice set. In today's session, we will look at the second topic, which is called section formula. We have studied distance formula where we derived where we derived the distance formula, which looks like this. If the 2 points are x1, y1 and x2, y2, then we derived that the distance between them will be given by this formula, x2 minus x1 square plus y2 minus y1 square. We also realized that we can write the y terms first and then the x terms. We also realized that within the brackets, we can write the ones x1 and y1 before y1 of x2 and y2. That also will not change the formula. It will not change the final answer because we are squaring the difference. So very clearly, we need to know some things about surds. Before moving forward, just to warm up and just to refresh what we have learned so far, quickly find the distance between these points. The points are A 3, 3 and B -4, -4. Solve it completely in your notebook and then share the answer in the chat box. Do it now. So the general formula is square root of x2 minus x1 square plus y2 minus y1 square. This is the formula. And again, I remind you that we can interchange the x terms and y terms. We can also interchange the x1s with x2s and y1s with y2s. So we can write the distance between x and A and B can be, and I'm writing it in a way that will be easier for me. Maybe you will have a different view of this. 3 minus 4 plus square. What did I do here? This 3, this -4. Okay. So instead of writing x2 minus x1, I have written x1 minus x2. This is also fine. Then plus, once again, 3 minus -4 cos square. What did I do here? Now I've taken this 3 and this -4. So instead of writing y2 minus y1, I've taken y1 minus y2 because I like positive numbers. That's the only reason. So we have the square root. 3 plus 4 is 7 square. 3 plus 4, 7 square. Now this is 7 square plus 7 square means 2 7 squares. Now, when we apply the square root, there are 2 7s, one will come out and the 2 will remain inside. So the answer is 7√2. The distance between the points A and B, where the coordinates of the point A are 3 and 3, and the coordinates of the point B are -4 and -4. The answer is 7√2. Chand, when you wrote 2√49, it is wrong. No? 2 cannot come out. 49, I know where you are getting from, 7 into 7. Akhilesh and Rajesh, you see what you missed. You missed the square root. You have just written 98. 98, where did you get 98 from? 49 into 2. So most of you are almost getting the maths right, but there still needs to be a lot of improvement in how do we write the perfect answer. We are far from it. But of course, many more and more of you every day are getting the maths right. Chand, Akhilesh, Rajesh, please confirm that this is my feedback is clear. Khadija, your answer was perfectly written. Karthik, your answer was also perfectly written. Thank you for the confirmation. As I said, we will study the next topic today. Remember, there are three main topics in this chapter. One is the distance formula, second one is the section formula, and the third one is slope of a line. We have completed distance formula. So today we will proceed and we will start studying section formula. And just like what we did for the distance formula, here also we will see how the formula is derived, and then we will use the formula to answer different types of questions. But even before we start understanding the section formula, we need something else. We need to remember, we need to know something else that we have studied in the previous classes. And it is something related to parallel lines. I'm sure you would recognize this kind of diagram. Where there are three parallel lines, L, M, and N. And there are two other lines, P and Q. If I tell you that L is parallel to M is parallel to N, then what are the special names? What is the special name of the lines P and Q? Do you remember? Can you share? So if we say that L, M, N are parallel to each other, then we see that lines P and Q, they are intersecting these parallel lines, and such lines are called transversals. Transversals. And together they give rise to something called as intercepts. Intercepts are parts of the transversals that are between the parallel lines. So the intercepts here are AB, BC. There are two more intercepts. Can you identify the other two intercepts? Speak or type.
DE, EF.
Correct. DE and EF. And we studied a relationship between these intercepts using what theorem? Do you remember? Very basic theorem, which is called basic proportionality theorem. Right? We understood that when this happens, when there are three parallel lines or more, and there are multiple transversals intersecting them, then the intercepts are in the same ratio. They are in proportion. That means the ratio of AB and BC will be equal to the ratio of DE and EF. हमने ये क्वेश्चंस किया है ना, हमने कहा let AB be 6 centimeters and say BC equals to 3 centimeters, and then if we see that EF equals to 2 centimeters, then DE will be how much? Quickly tell me, how much will DE be? Using the formula, the relationship that I have written on the screen, how much will be DE in this question? Very good, Prachi, correct answer. No, Khadija, wrong answer. Arti, correct answer. Arti Bania. Karthik, correct answer. Akhilesh Rajesh, correct answer. So you see, the ratio between AB and BC in this case, for this question, it is 6/3, which is 2/1. Now we don't know how much DE is, but we know EF is 2. Now from these two fractions, if we do the cross multiplication, DE will come to 4, right? 2 times. 2 times. Simple. Now this knowledge that the intercepts made by transversal on parallel lines are in same proportion. This knowledge is required to understand what the section formula is. So please make a note. Once we have understood and once we have remembered what happens to the intercepts of different transversals on multiple parallel lines, let us understand what is the meaning of the section formula before we understand what it is. What is the meaning? Section formula deals with division of a line segment. Section formula deals with division of a line segment. What do we mean by that? Suppose we start with the line segment AB. AB is the line segment. If I ask you, what is the length of the line segment? What will be your answer? What is the length of the line segment AB? Correct? It is very clearly 16. AB is one straight line because I'm telling you it is a line segment, and clearly it has two parts, AP and BP, where why is it 16? Because AP equals to 6 and BP equals to 10. When we add them, we get AB equals to 16. Now, when this type of thing happens, we also see that A, P, B. When we write like this, it means A, P, and B are collinear, where P is in between A and B. And this point P divides the line segment AB in a particular ratio. What is that ratio? Even if you don't know the numbers, but just by looking at the diagram, the ratio in which P divides AB is AP by BP. दो टुकड़े है ना? AP by VP. Now in this particular case, AP equals to 6, VP equals to 10. We know that we can simplify such fractions, we can simplify such ratios. Both 6 and 10 are even numbers, both are divisible by 2. So 6 divided by 2 is 3, 10 divided by 2 is 5. We can also write it as 3 by 5, or we can write it as 3:5. And we can say P, the point P, divides the line segment in the ratio 3:5. Point P divides the line segment AB in the ratio 3:5. Now, what section formula will help us is to find out where this P is. Or if the ratio is given, we can find out where that P is. Or if P is given, we can find out in what ratio that point divides the line segment. You see, in this example, AB is a very simple line segment. It is resembling a normal line, number line. But we know that this is not the general case. This is a very special case. And here we don't even have the second coordinate. We can just find out A, B, P, everything, the length between A and B and P, everything, just by one number for each of the points. In reality, though, we have a different situation. Let us see what we have. We have a system like this, which we call as the coordinate system. And it is not our enemy, it is our friend. It helps us simplify things. Now you see, AB is not a special line. It is a general line. A is any point with coordinates x1 and y1. B is any other point with coordinates x2 and y2. And when we join any two points on the plane, we will have a straight line. Here we have also shown the x-axis and the y-axis. They are intersecting at the origin O. Right? And P is a point on the line AB. And we are assuming, just say, just for sake of argument, that the coordinates of P are x and y. There are so many x's, there are so many y's. Already we have 6 variables: x, x1, x2, y, y1, y2. 6 variables already. So once again, the section formula will be able to, using the section formula, we will be able to find out where exactly P is. That means what is the value of x, what is the value of y. Also, if the exact values of x and y are given, we will be able to find out what is the ratio, of these two parts of the line. Which parts? Part 1 and part 2. So from the point, we can find the ratio, or from the ratio, we can find the exact location of the point. This is the meaning of section formula. This is what we are going to study. With that background, with that nomenclature in place, as in we are trying to find a point, we are trying to locate the exact point that divides the given line segment in a particular ratio. That is what section formula will help us do. Let us derive that formula. So we will add some details to the previous diagram. And very quickly you will understand why we did this and how it is related to what we studied as prerequisite. So we have 2 points, any 2 points, x1, y1, which is point A, and x2, y2, which is point B. So when we join these 2 points, we will have a line segment here. The line segment is AB, clearly. And there is a point P on the line segment AB. We don't know where it is. We will say it is somewhere at x, y. It is somewhere at x, y. Right? We are trying to find out where that x is, or what is the value of x and what is the value of y. We already know certain other things. We know that if we draw the perpendiculars from a point to the axis, then one coordinate will become 0 and the other coordinate will remain same. So if we draw the perpendiculars from any point to the x-axis, the x coordinate will remain same, but the y coordinates will become 0. So if we draw the line AC perpendicular to the x-axis, then its coordinate will be x1, 0. Similarly, the coordinates of the point Q will be x, 0, and the coordinates of the point D will be x2, 0. Now let us see what happens when we start looking at this line segment AB in conjunction with, along with another line segment CD. You see, AC is parallel to AQ is parallel to BD. I'll write that again for you. AC is parallel to I'm not able to see this point. AC PQ is parallel to BD. Why, you will ask? 90 degree, 90 degree, 90 degree. Corresponding angles. Test. So AC is parallel to PQ is parallel to BD. If that is the case, what can you say about the line segment AB and the line segment CD? What are they? You know it already. You have identified such line segments before. Try, tell. There will be a special name for the line segments AB and CD. If we see AC parallel to PQ parallel to BD, yes, they are transversals now. Okay. And this is the connection. This is the connection with what we have studied. What we saw when we revised was an example, a diagram like, one second. When we revised the intercepts of parallel lines, we looked at a diagram like this, right? Now something has changed. Now we have the parallel lines which are vertical, and the transversal are like this. That is what has happened, nothing else. So the logic will still apply, that the intercepts will be in the same ratio. Now let us first identify the intercepts. I will identify some and you will identify some others. On the transversal AB, this is the intercept AP. The other intercept is BP. Now look at the other line segment CD and tell me what should come in the numerator and what should come in the denominator. Very good. Correct answers in the chat. It will be this intercept and this intercept, which is CQ by QD. Right? This is what will happen. So our AC is parallel to PQ is parallel to BD. AB and CD are transversals, which gives rise to 4 intercepts, 2 on AB, AP and 2 on CD, which are CQ and CD. And we know from basic proportionality theorem that these intercepts will be in proportion. They will form equal ratios. Their ratios will be same. Okay. Now AP and BP may be a little difficult, but CQ and DQ, to find the length between CQ and DQ is very easy. This is a special case, distance between 2 points that are on the x-axis. Tell me what is the difference between C and Q? You know this already. What is the distance between C and Q? Okay, Khadija, I will take your answer. X minus x1. And what is the distance between C and 1? C and D. Karthik, your answer is also correct. What is the difference between C and D? Correct. X2 minus x. Okay. So what we can also write is, we have found out that CQ is x minus x1, and we have found out that QD is equal to x2 minus x. This is very, very basic. This is not class 10 maths. From here, we can do further algebra and find out the exact coordinates of x and y. Remember what I said. If we know the ratio, then we can find the coordinates x and y. Also, I said, if we know the coordinates, then we can find the ratio. Okay. So for this derivation, let us assume that P divides the line segment A and B in the ratio m:n. That is m by n. This is what we are saying. Let us see how the derivation can be completed. So on the previous page, this is what we found. If we take what was there on the extreme left, it was m by n. And if you take what was on the extreme right, it was x minus x1 by x2 minus x. You only told me. Now just using algebra. So we will take this m to the left hand side, and we will take this x2 minus x1 to the right hand side, or you call it cross multiplication. We get this. Now we start simplifying. So n into x is nx, n into minus x1 is minus nx1. Similarly, mx2 minus mx. Now, if we keep x's on one side and other things on the other side, because we want to find x. So what we will do is we will keep the nx as it is, and we will move the mx to the nx side. So minus mx will become plus mx. And we will keep everything else on the right hand side. So mx2 remains where it is, and minus nx1 moves from left to right. It becomes plus nx1. Now between mx and nx, x is common. We are left with m plus n. In the final step, when we move this m plus n, because x is now here multiplied with m plus n, if we move this to the right hand side, multiplication will become division, and we get the value of x as mx2 plus nx1 divided by m plus n. When we say we have found the value of x, how are we saying that? Because we know the ratio m is to n, so we know m and we know n. We also know the points a and b, so we know x1 and x2. So putting the values of m and n and x1 and x2 in the formula, we can find the x coordinate of the point P. Similar algebra, similar geometry can be used to find the y coordinate. Let us try do that. In the same diagram, instead of drawing perpendiculars on the x-axis, if we draw perpendiculars on the y-axis, what will happen? We will have lines like this. Now the points will be, now the x coordinate will become 0, 0, y2, 0, y, and 0, y1. Now the parallel lines are this, this, and this. The transversals are this and this. So the ratio, equal ratio of the intercepts, one intercept, another intercept, third intercept, and fourth intercept. In the ratio m is to n. So if we use the same logic, we can also be able, we will be able to derive the value of y. Let us see what it will be. If we do that, if we do what we just discussed, we will find out y will be equal to my2. Now you tell me what will be the next term. Speak or type. Y will be equal to my2 plus ny1, correct, divided by m plus n. Thank you for the interaction on the chat. So using the basic knowledge of intercepts made by transversals on parallel lines, we are able to find out the coordinates of a point that divides a given line segment in a particular ratio. So what is definitely given in this case, I'm repeating, please make it absolutely clear. What is given? x1, y1, we know. x2, y2, we know. M is to n, this also we know. We know this. What we are able to find is x and y. This is what we are doing. And another use of the same section formula is, If x1, y1, x2, y2, and x and y are given, then we will also be able to find out m and n. We will see that today. This is the theory for section formula. We can summarize it like this, that if there is a point with coordinates x1, y1, and there is another point B with the coordinates x2, y2, and there is a point which divides the line segment joining these 2 points, then the coordinates of that point P, can be calculated by the formula mx2 plus nx1 by m plus n, comma, my2 plus ny1 divided by m plus n. That is the theory. Now let us see how we can use the theory. Very easy, very, very easy. Have your textbooks, notebooks, pens, pencils ready. We will start with a solved example. This example, which is example number 1 on page number 110, page number 110. It reads, if A is 3, 5, B is 7, 9, and point Q divides segment AB in the ratio 2:3, then find coordinates of point Q. Very straightforward question. And our answer will be also very, very straightforward. So now help me solve this question, and you will speak or you will type. So if I ask you, what is x1? What is y1? If I ask you, what is x2? What is y2? If I ask you, what is m and what is n, what will be your answer? One by one. What is x1?
3.
What is y1?
7.
No. y1.
5,
Correct. What is x2?
7,
And what is y2?
9,
What is m?
2,
What is n?
3.
3. Very good. Thank you, beta. Now we have to find the coordinates of Q. We will say let the coordinates of Q be x and y. So we will have x equals to, now you know the formula, mx2 plus nx1 by m plus n. Now we have m as 2, x2 as 7, n as 3, x1 as 3. Again, 2 plus 3. 2 into 7 is 14. 3 into 3 is 9. 2 plus 3 is 5. 14 plus 9 is 23 and 5. So x is 23 by 5. Now you will help me write y. Y equals to, I will write the formula, my2 plus ny1 by m plus n. Tell me what we will write. 2 into what?
2,
2 into?
9,
2 into 9 you are saying, yes.
plus and 3, 5.
3 into 5 divided by 2 plus
2
3.
plus
Thank you.
3.
So 2 into 9 is 18. 3 into 5 is 15 by 5. 18 plus 15 is 33 by 5. So we have found x and y. Have we found the answer? Yes. The coordinates of the point Q are 23 by 5, 33 by 5. This is the answer. Actually, in this part of the chapter, section formula, the midpoint formula, and the centroid formula are given together, but we are studying them separately. So we will look at another set of examples starting on page number 113. First example on page number 113. Do you think this question is any different from the previous question? If you think it is different, thumb up. If you think it is not different, thumb down. I think you did not understand the question. I said, if it is different, show me a thumb up. If it is not different, show me a thumb down. It is not at all different. Once again, 2 points are given. A minus 7, 4, and B minus 6, minus 5. And what is given is the ratio 7:2. We have to find the coordinates of this point T, which divides this line segment B in the ratio 7:2. Conceptually, this is exactly the same as previous question. Only difference is, if you can call it difference, is the values, the coordinates, and the ratios. Otherwise, nothing is different. Once again, easy question, easy solution. Very clear solution though. How much is x1? How much is y1? Quickly, x1 and y1.
-7,
Minus 7 and
-6,
no.
4,
y1.
4, 4, 4, 4.
Yes, be careful. Then x2 and y2. How much is x2? How much is y2?
-6,
-5. -6 minus.
-5.
Very good. Now, what is m and what is n?
7,
7 and
2.
very good. Now you've got it. Now again we have to find x. mx2 plus nx1 by m plus n. Check if sir has written the formula correct. First check the formula. I don't know. I keep doing everything wrong. Check and confirm.
X1 or Y1?
Yes, this should be y1. Good. So x will be calculated as mx2 plus nx1 divided by m plus n, and y can be calculated as my2 plus ny1 by m plus n. Just put the value and see what values what final numbers you are getting. Do it in your notebooks. Of course, you will need to know your integers. Class 5. 7 into minus 6 is minus 42. 2 into minus 7 is minus 14. 7 plus 2 is 9. 7 into minus 5 is minus 35. Then 2 into 4 is 8. 7 plus 2 is 9. Minus 42 minus 14 is minus 50. 9. Then minus 35 plus 8 will be minus 27 by 9. 27 is divisible by 9. So this will be minus 3. Minus 56 by 9 and minus 3. How will we write? Minus 56 by 9 and minus 3. The logic remains same, but now since the coordinates are no longer just positive numbers, we have a combination of both positive and negative numbers. That is, we have integers, then the arithmetic looks a little bit complicated. Remember, the coordinates can also be fractions. The coordinates can also be decimals. Those are basic things. What new thing that we have studied is the formula. mx2 plus nx1 by m plus n, my2 plus nyn, ny1 by m plus n. That's all what we are studying new. Next question on the screen is a direct question from practice set 5.2. This is question number 1 of practice set 5.2. Take your time, solve it properly in your notebook, take a picture, send it to me on WhatsApp. Write it properly. So this question is again conceptually exactly same as the two example questions that we saw just now. What only the values are different. That's okay. So in this case, we can say our x1 is 1 minus 1, y1 is 7, our x2 is 4, and y2 is minus 3. Our m is 2 and n is 3. Right? So AB is the line segment which is divided by the point P in the ratio 2:3. We have to find out the coordinates of P. So we will say let the coordinates be x and y. We know x can be found out by the formula mx2. Chanda, here is where you got it wrong. The formula itself plus nx1 by m plus n. Our m is 2, x2 is 4, n is 3, and x1 is minus 1 by 2 plus 3. 2 plus 4 is 8, minus 3. 3 into minus 1 is minus 3. Then 2 plus 3 is 5. 8 minus 3 is 5. 5. Now many of you are not doing this also. 5 divided by 5 is 1. We got the first coordinate, x coordinate as 1. Now the second coordinate, that is y. Now my2 plus ny1 by m plus n. Chanda, once again got the formula wrong. So this will become 2 into minus 3 plus 3 into 7 and 2 plus 3. 2 into minus 3 is minus 6. 3 into 7 is 21. 5. 21 minus 6. Minus 6 plus 21 is 21 minus 6, which is 15 by 5 equals to 3. Remember, Anushka Chand, you got this wrong. You got this integer operation wrong. Be careful. So the coordinates of the point P are 1, 3. Simple. Try question number 2, part 1 of practice set 5.2. It reads, in each of the following examples, not examples, questions, find the coordinates of point A which divides the segment PQ in the ratio A is to B. Okay, there is a coach. P is given, that means x1, y1 are given. Q is given, that means x2, y2 are given. A is to B. Instead of calling M is to N, it says A is to B. No problem. Solve. Find out the coordinates of the point A. I'm solving it on the screen now. In this question, the x1, once again, sorry. In this question, we can say that our x1 is minus 3, y1 is 7, x2 is 1, y2 is minus 4. And yes, we can say m is 2, n is 1, or we can use a and b also. It is up to us. Once again, we have to find x and y. So our x can be mx2 or ax2 plus nx1 or bx1 by m plus n, or we can write a plus b. Both are correct. I will write that also. ax2 plus bx1 by a plus b. Both are same. So it will be 2 into 1 plus 1 into minus 3. 2 plus 1. 2 into 1 is 2. 1 into minus 3 is minus 3 by 2 minus 3 is minus 1 by 3. So our x coordinate is minus 1 by 3. Similarly, if we have to find y, the general formula is my2 plus ny1 by m plus n. We can also write it as ay2 plus by1 plus divided by a plus b, which will be 2 into minus 4 plus 1 into 7 divided by 2 plus 1. 2 into minus 4 is minus 8. 1 into 7 is 7. 3 minus 8 plus 7 is minus 1 by 3. So the coordinates of P are minus 1 by 3, comma, minus 1 by 2. Simple, no tricks, nothing. Another type of question is like this, which is example number 3 from page number 113. Remember, I'm skipping example number 2. We will go there later. Example number 3 reads, A is a point with coordinates 15 and 5, and B is another point with coordinates 9 and 20. And APB, it's again saying the same thing, that APB are collinear points where P is in between A and B. Find the ratio. Now see, here is the difference. Now the ratio we have to find the ratio in which the point P coordinates are given 11, 15, divides the segment. Now this is clearly x1, this is clearly y1, x2, y2. Can you tell me what is 11? 11 is the value of which variable in general? Speak or type. X, correct? And 15 is the value of the variable y. Then what is it that we have to find? We have to find two things here. What is it that we need to find? M and N. Very good. We have to find M and N. If we find M and N, we can also find M is to N. We have to find the value of M and we have to find the value of N. And we will use the same formula, nothing new. Right? But the values that we know and the values that we need to find out, they have changed. So the general formula that we have is x equals to mx2 plus nx1 by m plus n. In the previous two examples, we had m, n, x1 and x2. We found x. In this question, we have x1, x2 and x. We have to find m and n. We have to find m and n. So what this means is our x is 11. So we can write 11 equals to m, x2 is 9. So 9m we can write. Then n we don't know, x1 is 15. So 15 n by m plus n. Now if we take this m plus 1, which is the denominator, to the left hand side, it will become 11m into 11n. 11 m plus n will be equal to 9m plus 15n, or 11m plus 11n equals to 9m plus 15n. Now whenever this comes, you know whose name comes to my mind. 11m minus 9m plus 11n minus 15n. So I've taken everything to the left hand side is 0. 11m minus 9m is 2n. 11n minus 15n is minus 4n equals to 0. 2 and 4 both are divisible by 2. So divide everything by 2. We get m minus 2n equals to 0. This is equation 1. Now Chand will say this is a linear equation in 2 variables. Similarly, using the formula y equals to my2 plus ny1 divided by m plus n, and here the value of y equals to 15, we can find another equation, linear equation in 2 variables in m and n. And we can solve these 2 equations, whichever method we want to use, to find the value of m and n. Look at the solution in the textbook. See if you are able to find. This is one way. Write the equation. Write the equation for the y formula and tell me what you are getting. And then sir will tell you, why are you doing all those things? We don't need to do this. Yes, we don't need to do this. Why? Because hang on. Don't be in a hurry. We don't need another equation. Really, we don't, because from this equation only, we can say m equals to 2n. So m by n. Now, if we bring n to the left hand side, m by n equals to 2. That means equals to 2 by 1. So the ratio is 2:1. And we can find the same thing if we use y formula. If we use the y formula. Let me write it once again in another way. From here, instead of doing what I did just now, what we could have done is this. We will keep all m's on one side and we will keep all n's on the other side. So 11 minus 9 is 2m. 15 minus 11 is 4n. Now we will bring m to the left hand side and we will take 2 to the right hand side. So m by n equals to 4 by 2 equals to 2 by 1. Right? So the ratio is 2 by 1, 2:1. Question number 3 of practice set 5.2. Conceptually exactly same as example number 3. It says find the ratio in which the point. So the point coordinates of the point which is dividing the line segment is given. T minus 1, 6 divides the line segment joining the points P and Q minus 3, 10 and 6 minus 8. Solve it in your notebooks. And for a change, let's use the y wala formula and see if we are able to do the same trick. You're solving it in your notebooks. Use the y formula. Pay attention to the screen. Let's see how we can solve this very easily. So we need to find m and n. We don't know. But we know that here y is 6, and if we use this formula for y, so we can say y2 is 8 minus 8, so minus 8m. Then y1 is 10, so 10 m1. Let me write it properly. 10n by m plus n. So now 6m plus 6n equals to minus 8m plus 10n, or 6m minus plus 8m equals to 10n minus 6n, or 6 plus 8 is 14m equals to 10 minus 6 is 4n, or if we interchange the move n to the left hand side, and if we move 14 to the right hand side, so m by n equals to 4 by 14. 4 and 14 both are divisible by 2. Mathematically this is correct, but this is not the best answer because the ratio is not in the simplest form. Both 4 and 14 have a common division, which is 2. So 4 divided by 2 is 7. 14 divided by 4 divided by 2 is 2. 14 divided by 2 is 7. So m is 2. mn is 2 by 7, or 2:7. So the ratio in which point T divides the line segment PQ is 2:7. Example number 2, page number 113. Example number 2, page number 113. Nothing, no new logic, no new theory, but another type of question. It says if point P minus 4, 6 divides. So the point that divides the line segment is given, very clearly given. The coordinates are minus 4 and 6. So we know that this can be X and this can be Y. Divides the line segment AB. So X1, Y1, and our X2, Y2 are not given. X2 and Y2 are not given. But what is given is the ratio in which they are divided. That is, M and N are given. So once again, using the basic formula, we can say our X equals to Mx2 plus Nx1, M plus N. Now in this case, we know our X, which is minus 4, which is equal to M is 2. So 2 into R plus 1 into minus 6. So it will become minus 6 divided by 2 plus 1. Solving this, we will be able to find R. Similarly, Y equals to My2 plus Ny1 by M plus N. We know that Y is 6. Now, applying the same formula, 2 into Y2. Y2 is S. So 2S. 1 into Y1. Y1 is 10. This is also another linear equation. When we solve these, from here, we will find out the value of R. From the second one, we will find out the value of S. So we will be able to find the coordinates of the point B. Check the solution in the textbook. Ask me if you have a doubt. Try solve question number 5 of practice set 5.2 on your own in your notebooks properly. Take a picture, send it to me. We have enough time to complete this. This question doesn't need any new theory. This question doesn't need any new logic. It just needs application of the appropriate logic. What we have in this question is X and Y. X equals to K, Y equals to 7. We have X1 and Y1, which are 8 and 9. Thank you, Anushka. Got your answer. Also, we have X2 and Y2, which are 1 and 2 respectively. Now, two things we need to find. We need to find the ratio in which the point P is dividing the segment AB. We also need to find the value of K. It is up to us कि हम पहले कौन सा पता करने की कोशिश करते हैं, right? But smart ones will realize that we will have to find the ratio first. You will understand why. Let's see. So if we try to find the ratio first, remember, we can find it from the X formula. We can find it from the Y formula also. Here we don't know X. X is K. We still don't know the value of K. So we will use the Y formula. So if you use the Y formula, which is Y equals to My2 plus Ny1 by M plus N. Here Y is given as 7. So our 7 equals to ratio M into Y2. Y2 is 2. So 2Y2. 2Y2. Then what is our Y1? Y1 is 9. So 9 Y1. Is it right? Is it not right? It's not right. I should have written 2M plus 9N by M plus N. So we can write 7M plus 7N equals to 2M plus 9N. Using the same algebra, 7M. Wait. 7m minus 2m equals to 9n minus 7n, or 5m equals to 2n. Therefore, m by n equals to 2:5. We found the ratio. So from here, this is one answer. From here, we can say that we can use m equals to 2x or 2k or 2a, something like that. We will not say m equals to 2. That will not be perfectly right. Huh? But yes, if you are using it, okay, I'll think about it once again and tell you if you can use it. We cannot say m equals to 2 and n equals to 5 because these are ratios. We can only say mathematically the right thing to say would be some ratio. So 2 are something like that. But anyway, so keeping it simple. If we say m equals to 2 and n equals to 5, in the next step, what we can do is clearing the screen. It's 2:5 now, right? So in the next step, we can say, now if we use the x formula, right? So our x equals to mx2 plus nx1 by m plus n. Our x is given as k, which is equal to 2:5. So 2 into x2. x2 is how much? 1. So 2 into 1 is 2. Similarly, you will complete this equation and you can find out the value of k, which you will find it as find it to be 6. You will just put the value of m and x1, x2 and find the value of k. That's what some of the students have successfully done. You will very easily find the value of k. This is how we can solve question number 5 of practice set 5.2. There are some other types of questions also related to the section formula that we will see in the next class, which is example number 4. We will look at, till now we have seen only one, we have seen a point which divides the given line segment. We have seen a point which divides the line segment in 2 parts. But what if there are more points and the line segment is divided into more than 1 parts? That is what we will study in the next class. We will, so you will read it and read this and come. We will also look at the midpoint formula and the centroid formula. So we will also cover another thing which is called external division in the next class. I'm changing your homework. So you will not solve question number 3, example number 4, and also this. So you will read example number 4 on page 114, and you will try questions of practice set 5.2. Which questions? The questions are 10, 11, and 12. Okay, so homework has reduced from what I had planned initially. That's fine. And submit it before the next class, that is tomorrow, Tuesday, 7th of September.